Okay, so this is a continuation of my quick change tool post video that I did a while ago. In that last video, I said that I wanted this to be lower. In order to do that, I need to get rid of the compound here and then mount this right to there. And in order to do that, I went to my local favorite steel place and I bought a scrap of steel. And this is a pretty chunky piece of metal there. And I also bought a tap that is a focus. It's a 5/8 by 18. Camera's not focusing. 5/8 by 18 tap, and that is the same as the thread here. So the plan is, what I need to do, I need to take this off, take some very accurate measurements of how it mounts to here, and then put that in a chuck, and then turn it down to fit, drill and tap a hole in the middle for that post to thread into, and then I will be able to replace this with this. That will be about an inch lower, and then I'll have more options as far as tools to use here. So let me get some stuff done, and we'll come back when I can actually show you something that looks like something. All right, there's that piece off and just sitting there. I forgot about this post right here. I completely forgot that was there because I was planning on having the new tool post come in right in the middle, but I'm going to have to bore a hole in the middle of this to go over top of that hole, and that would only leave me with, I don't know, about a 1/4 inch worth of threads for that center post, so I can't do that. So on this piece, I'm going to have a hole right in the middle that fits perfectly over that, and then the threaded hole off center, so the tool post thread will come down here. So again, I'll have a reamed hole to fit that, and then about here, a threaded hole for the tool post thread there to thread into this. Then I'll have to drill 2 holes to pick up those 2 bolts. And you'll notice that this is actually thicker than those bolt studs are tall. So I'll have to counterbore down a little bit so the nuts will set down in there. But that's good because then I don't have to worry about those posts or the nuts getting in the way of mounting this to the top of this. So that should work out fine. Let me get some measurements made. I'll make some drawings. Then I'll put that back on so I can face that off and bore the hole. And I will also turn it down to the right diameter. It's going to be a lot coming off. I might tree pan it or something. I don't know. I've never done that before. Or I might just make a line and take it to the bandsaw, cut off the excess on the bandsaw, and then true it up on the lathe. I don't know. I'm just kind of making stuff up as I go along. But I'll get back to you when I got some stuff done. All right, so this piece is done, and I'll tell you, it was quite the struggle. You remember when I said I was going to put the whole thing in the lathe and just turn it down to the right diameter? Yeah, well, that didn't work because this was too big to fit in any of my chucks back there. It was about 1 inch in diameter too big for the jaws to open up for that to fit. Not even 1 inch, like maybe 1/2 inch. So you can kind of tell what I did, maybe. I put that in a drill press, and I just drilled about 75 little holes all the way around, and then connected it with the bandsaw. And because, you know, for one reason, the bandsaw blade is a little bit wide and not meant to make curves. Plus, cutting through that thick of material for that long with just the bandsaw would have taken like a full day and a half, I think. So drilling all the holes was a little time consuming on the drill press, but it sped up the job of the bandsaw a lot by, you know, because like half of that path was done with the drill bit, with the drill press. So anyways, I finally got that piece cut out. Then I could put that in a lathe and basically just clamp half of it, turn the diameter and face it off, and then flip it around and clamp half of it, turn the rest of the diameter. You can see the line because I just use a 3-jaw chuck. You know, when you use a 3-jaw chuck and you take a part out and flip it, you lose concentricity, which for this is no big deal. I don't care about that. But you can see the line there where I had turned half down and flipped it and turned the other half down. Of course, faced each end. And then put the hole in the middle for that post there. And then drilled and tapped for the tool post there. And then drilled in and counterbored for the posts and the nuts here. So fairly simple machining operations, but I tell you, I struggled with almost every part of it. Boring that down for the nuts to go in, I had to bore down about 10 millimeters, which isn't much, but my end mills, I've had, you know, the only end mill I had that was that big was kind of chipped, and it chattered like a lot. So I could have bought a new end mill, but instead I decided to torture my milling machine, and it just chattered like a lot, and it took forever to get down there. But I finally got those bored out, and so now this goes on like that. You see the posts come through here. It's a nice, perfect, tight fit. I did manage to kind of nail the dimensions pretty much exactly the way I wanted it. The only thing though, you know, that surface finish isn't the best. I don't know what kind of steel that is, but it did not want to turn on the lathe very well at all. I tried different cutters, different depths of cut, like everything, and it just did not like being on the lathe at all. It drilled nice. Like when I drilled all those holes in the drill press, it drilled nice. When I drilled those holes, it drilled nice. But just turning on the lathe, just did not like it. If we put these nuts on here, and I did, you know, I made that pocket big enough for a socket to go in there. Okay, so that's those tight. And you could tell here now how that's lower than that surface, so that's good. And then this can go on there. And for this piece, I wanted it thick enough to make sure I had plenty of thread for this to screw in. So I've got all the threads in there. Ideally, this needed to be thicker because this is about 18 millimeters thick. And it needed to be about 25 millimeters thicker. Because right now, when I put that on here, now I've got the opposite problem I had before. Now it's too low. It's about an inch too low. But if this was an inch thicker, yeah, I would still be cutting this thing out and counterboring that down another inch to get the nuts to reach the threads. Yeah, that would have been a nightmare trying to cut a chunk of steel almost 2 inches thick. So I didn't want anything thicker than I needed for the threads, but I didn't want anything thinner because, again, I wanted all the threads there and I didn't want the block too low. So I kind of knew I was going to have to make this to mount everything down to and then put a spacer block in here. So I made this first and then put that on. And so with that on, then I could take one of my cutters, my tool holders, trying to do this one-handed, and bring that over to a center point. And what I did was I positioned this about halfway, approximately halfway, and I would raise this up until the cutter was at the right height and just measured how high up that was. And it's about an inch. Let me get those spacer blocks under it and I'll show you what that looks like. Okay, so now I've got about an inch of space, bringing that up. Still plenty of thread there for the nut. And now I can get the cutter tip at the correct height there. And that's my little short, small cutter. And if I put on one of my normal cutters, I can also get that at the correct height now too. And again, it's at about a middle height here. So with about an inch spacer, I'll be able to use any of my cutters and still have plenty of adjustment up or down. Unfortunately, I don't have a chunk of metal an inch thick that's big enough to make that part out of. And for that, aluminum would be perfectly fine. It doesn't have to be steel. Aluminum would be fine, but I don't have a single chunk of aluminum that thick and about 2.5, 3 inches square. So I'm going to go have to buy something. But until then, I can just use scraps to space it up. I mean, if I clamp that down, those pieces aren't going anywhere. I could drill a hole in this, just so it's not sticking out like that. So for now, this would work. This would be fine. But I do need to go buy an actual piece of aluminum. That light. You know, I'm glad I have a light here, but it's always not in the right spot. But anyways, I'm going to end this video here because it's way too long of a video for talking about a little steel block to space that up. I'm not going to make another video about cutting a piece of aluminum and drilling a hole in it. But the next time I'm doing a project on the lathe, you'll probably notice a chunk of aluminum spacer in here. It'll be purpose-built. It'll look good. But anyways, this is what I had to do to make this work on this lathe. I don't know that this is the right way to do it, but it seems to work. Or it seems like it will work. So anyways, like I said, I'm going to end it here because this video is way too long for what I wanted it to be. So as always, until next time, thanks for watching.